Hello and welcome back. We're going to start coding the doubly linked list using Python. Right now I have the Python shell open in front of me. You can use PyCharm, Python shell, idle shell, Gianni, whichever editor that you want. It's not a problem. And I'm going to jump straight into it. One thing just as a remark, this is going to be very similar to the singly linked list. That is because a doubly linked list is a singly linked list with one additional pointer. So you're going to see that almost everything is going to be the same, but we're going to have that additional pointer to work with and customize. So first things first, I'm going to start creating my class. Again, class node, same old class that we used, and I'm going to start with Thunder for initialization. Now, some of you went through so many problems when they were copying this program or working with the program, from the singly linked list because of one of two things. One, they didn't have those under. They wrote define it. Define init is any method. Python doesn't understand that that is a constructor. But under initialization under, that means constructor, which means whenever an object is created from this node class, from a class, first of all, call this constructor that we have, finish it, and then work on the remainder of your object. So under init under, and we call that dunder init. So this is going to receive the self and data that we're going to send to our method. What we want to do here is, of course, give our data to self.data equals data. So this self.data is a variable that we just created. This data is this data in here. And if you want to, we can remove this, like D and D, but I would prefer to keep it as data so that your code is more understandable and more readable. Now, what we are going to do here is actually, sorry, I inserted the semicolon by habit, muscle memory. So self.next equals none. Again, this is exactly like simply linked list. But right here, we're going to add something new. It's going to be self.previous equals none. And that is the new thing. So our new node is going to have data, this data, next, and previous. So one data and two pointers. Right after that, I'm going to start creating the linked list. So class, this time we're going to call it Doubly linked list. Again, don't receive anything, don't need it in here. And we're going to do the initialization. So define under it. And this is for head. If you want to use tail, then you have to put it in here as well. So I'm going to self, and that's it, nothing else. I'm going to say self.head equals none. Now, in this example, I'm not going to use tail, but you are going to use it later on. It's going to be an assignment for you to do the exact same thing that we do in the doubly linked list, but in the other way. So I'm going to program everything from the head point of view, which means start at head and continue all the way to the end, from left to right. What you're going to program later on as an assignment is start at the tail and program all the way to the left. It's very simple. Believe me, it's more simpler than you think, but at the same time, you have to start looking at it from both ways. If I was to add a tail, it's going to be added in here. Self.tail is going to equal none. But I'm going to delete this, by the way. I'm going to work just with head. This is just as an example. Even if I added the tail, head should stay in here. Your linked list is going to start at head. Okay, so if head equals none, that means there is no linked list. Tail is going to always point at the last node in our doubly linked list, or even in our singly linked list. So even if I'm going to use tail, you should always have head that starts at the beginning and always work with it in the correct way. Because sometimes some of the students are going, if they work with tail, they're going to delete head, and that is a big mistake. Now, just like last time, I'm going to start to print. I want to do a method that prints so that I can at least make sure that the insertion or the removal that I'm going to do are working. And here I'm going to do, let's call it, what should we call it? Print DLL, the doubly linked list. It should receive nothing, it's a print, so it's going to print by itself. And we're going to say temp, or actually not temp, let's use current. So current equals head. And this is taking the same head that it has. I can say self.head, same thing. Self.head. Actually, both of them are going to work because we are inside of the class. We are still inside of the class. So down here, and we're going to do a simple traversal. And we're going to do while current is not equal to none. So what I'm saying in here is start at the beginning, at the head, while you are not none. Look, not current.next, but while current itself is not none. That means I want to keep on printing until I go to none, which means I print everything from the beginning all the way to the end, from the first node all the way to the last node. And then here we're going to print data. And of course, I want to have my separator in here. So my separator is going to be just a space. If I stop here, then I'm going to go into an endless loop, which means it's going to check current equals self.head. It's going to take the first link, the first node in our linked list. And then it's going to say, okay, print current data, let's say it's 5, and then it's going to come back. Are we at none? And in reality, no, because we are still at the same node. We didn't move, and it's going to print 5 and 5 and 5 and 5. So what we need to do in here is add a motion in our linked list, and that is going to be by doing current equals current next. So the idea in here, the main idea here is that I print the first one, then jump to the next, check did I reach none, print the next, jump and jump and jump, all the way until everything is finished. Now, at this point, there might be some clerical mistakes, some mistakes in the program. Because I'm a little bit tired, it's not a problem. We're going to finish that later on if we find any. At this point, we should have a class that has the node, a class that does the initiation or a constructor, and a class with a constructor method and a print method. So I'm going to stop here, and in the next video we're going to see how to insert or remove using the same program that we're working with right now. I'll see you soon.